Okay, let's talk about data. We have quantitative and qualitative data, and you may recognize and hear the word quantity and hear the word quality. So if you're looking at your, let's say, driver's license, there's a lot of information about you. Some things are quantities, some things are qualities. Oftentimes with quantitative, you want to say number stuff. And that's a good rule of thumb, but just because it's a number doesn't necessarily mean it's quantitative. We'll come back to that idea in a second. So if we're looking at our driver's license, I'm assuming you or someone you know has a driver's license or an ID card. What are some qualities on that ID, on that driver's license? Some good examples would be hair color, eye color, gender. Those are all qualities. Quantities would be something like something that's measured, something like your height or your weight or your age. Those are all quantities. So if you're looking at your driver's license, some information is definitely quantitative, others is definitely qualitative. Other stuff is a little confusing. I don't want to get into it right now because it'll just confuse you. But let's say, for example, here's a tricky one. Your social security number. Let's say it's 552-1717-8383 or something like that. So it's number stuff. So you're like, oh, well, if it's number stuff, it must be quantitative. No. Your social security number, like, what does it mean if someone's social security number is a bigger number than yours or a smaller number? It really means nothing. Your social security number is kind of just like your age. So it really has no quantitative meaning. You can't really compare it to another number and make sense of it. It's not like more or less means anything. So your social security number is, technically speaking, qualitative. Confusing, I know. But hopefully the examples I gave of things that were definitely quantitative and things that were definitely qualitative made sense. So quantitative, age, height, weight. Qualitative, eye color, hair color, gender. Okay. So these are just words we use to describe data. Sometimes when we're talking about number stuff, we say that numbers are either discrete or continuous. Discrete's easy to notice. Discrete means it's only going to take on nice values, nice whole number values. So, for example, the number of computers in your house. Either there's 0, there's 1, there's 2. No one has 2.37 computers, right? That doesn't make sense. So continuous stuff is when there is decimals. Um, so just be careful because some things in life technically should have decimals, but we don't use them. So for example, your weight. You don't actually weigh 138. You actually weigh 138.3718 pounds, right? There's actually, if you get on a good scale, there's actually some decimal stuff to it, right? LBS, pounds. Um, so your weight is technically speaking continuous. And your age is also technically speaking continuous. In America, I know, or the most of the world, we say you're either 21 years old or 21, but you're really not 21. You're actually 21 years, 5 months, 4 days. So you're like 21.374, blah, 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 years old. So continuous is when there's decimal stuff. So it's always easier to notice discrete. The number of cars at your household, 0, 1, 2, or 3. No one has 1.76 cars. Okay, we're just learning words to describe data. Sometimes they talk about level of measurement. So we have nominal. If you've taken a French class, nom, that means name. So sometimes there's data that's just like a category or a name, nom. So nominal would be something like your social security number. Yeah, it's a number, but it really has no meaning. It's just like, oh, hey, my name is 552-1717-5534. Maybe your major. Oh, I'm a math major. I'm an English major. History. So that's just nominal. Those are sort of categories. Um, ordinal, you'll see the word order. So the best example is things that have order. So like in a class, your grade is either A, B, C, D, or F. Is an A twice as good as a B? Is it 3 times better than a C? Is it 5 times better than an F? That doesn't really make sense. All I know is that there's an order. An A is better than a B is better than a C is better than D better than F. Okay. Or maybe in a marathon, someone finishes in first place, second place, third place. Was this person twice as fast as that person? Was this person 3 times as fast? No, that doesn't make sense. I can't really compare it like that. All I know is this person finished the race, and then this person, and then that person. There was an order. Interval is a little bit tricky. Common example is temperature. So when someone says it's 87 degrees, actually, technically, they mean it's somewhere between 87, what is it? It's approximately 87. So 87 degrees really means it's between like 86.5 degrees. Oh, someone keeps emailing me and driving me crazy. I should probably turn all my windows off. It's probably one of you emailing me. Okay. So 87 degrees just means you're in this range. You're approximately in this interval close to 87. Same thing with the year. Let's say we're talking about 2020. Aren't we technically talking about the interval from January 1st, 2020 all the way through December 31st, 2020? So the year, the temperature, those are all sort of intervals. Ratio makes more sense. So remember, in math, a ratio is just a fraction. So 40 over 20 is 2. Let's say someone is 40 years old, someone is 20 years old. Isn't that first person twice as old? Oh, division makes sense. A ratio makes sense. So age is ratio. Another example would be weight. Someone weighs 200 pounds. Someone weighs 100 pounds. Doesn't that person weigh twice as much? Ah, yes, a fraction, a ratio, division makes sense. So it's ratio. Okay. Hopefully that gets you through 1.1. Happy face.